Good day, grade 11 learners. Welcome to today mathematical lesson. My name is Mr. Mlefe AJ. This lesson is brought to you by Gauteng Department of Education in collaboration with Saibono Discovery Center and broadcast by Pagama Research and Development Center. Please, before we start the lesson, please have your calculator ready, your pen and your paper. You know, we are doing financial. We are going to continue with financial mathematics. So you need a calculator, please, a pen, and a piece of paper or a booklet. So let us continue. The lesson objective will be, at the end of this lesson, you should be able to, bulletin number 1, understand the effect of different periods of compound growth and decay, including nominal and effective interest rate. This one, it's very, very, very important. Please, and note, in effective and nominal, the formula is not given. So therefore, you need to memorize the formula when you enter into your exam room or a test room. So it's not given at the formula sheet. Let's continue. You need to be able to calculate involving changes interest rate. Yes, interest rate. And then bulletin number 3, involving addition payments and withdrawal. That's where I am going to introduce timeline to you. And then it will involve the addition and subtraction during timeline. No problem with that. It's already new to you. Let's proceed. Now, up to now, we have done annual interest rate. That's what we did. Compound interest is often compounded more often than once a year. It can be monthly, quarterly, etc. But you'll understand when you go on. And then it can be quoted per year, but calculated over different time period during a year. Okay, you'll understand when you go through. This one is only something that you need to know. So interest can be calculated. You talk about interest now. Annually, semi-annually, quarterly, monthly, and daily. Now let me try to explain this one. We've got terms here. It's terms, and then you've got I, you've got N. Now, if it's yearly or annual, our I is divided by 1 and N times 1. So anything divided by 1, it's equals to that thing. Anything times 1 is equals to that thing. So annually straight. And then when we speak of monthly, let me write monthly here. Please just do it. Just write it as I do. So here it's yearly, here it's monthly. Our I, we divide it by 12. And then our N, we multiply it by 12. Please just do it. And the next one, you need to know this one, please, before we go on. And then these are popular questions. And then quarterly. Yes, quarterly. Then what is our I? We divide our I by 4 and we multiply by N by 4. Listen, just listen. Quarterly, please take it as, let me draw the circle. It's a circle here. This one is half. Then quarterly, quarters, combine. This is quarterly. So how many do we have? 1, 2, 3, 4. Please don't write 3. I can make an example again of a loaf of a bread. This is our loaf of a bread. This one is half. So half is what? It's 1 over 2. It's 1 over 2. And then when I cut it here, it becomes what? A quarter. So that is why we divide by 4 and we multiply by 4. Most of you get confused when it comes to quarterly. Please just illustrate through that one. And then the next one is monthly. Of course, it's been explained. And then semi-annual. Semi-annual. Let's go to semi-annual or half yearly. The other way it can be, they can half yearly. So half, like I explained here, half. Yeah, it's our loaf. You cut it there. It gives us how much? 1/2. So half yearly, it's going to be I over 2. And then n, you multiply by 2. I think it's clearly now. We can just summarize it here. Please, I like to illustrate this one because most of you get confused about this, and then you're going to work more rapidly about this. So annually, it implies to a yearly, and then the difference between the two, like I said, I and N, straightforward. You're going to work a little bit more about this. So annually straight, semi-final, like I said, how much? You got semi is twice, né? Then quarterly is 4, monthly is 12, daily obvious, including leap year to be 365. So let me not waste more time on this one. Let us just proceed. But please don't forget the relationship. And then let us move on. Yes, annually it's once a year. Straight, like I said. Every 6 months, which means twice a year. Now we are just trying to explain it, but it's already been explained. I think I've summarized it. And quarterly is 4 times. It's twice. And then monthly, like I said, is 12. We've got 12 months in a year. And then daily, you've got 365, not including leap year. So please, this one, note them. They're very important because when you solve our problems, we're going to go through this one. Now prepare your calculator now and your pen, be ready so that we can use what is these examples here on a problem. So let us check the next one. I've got Beggy invested 20,000 for 3 years. Calculate the accumulated amount if the interest rate is 9%. Per annum, compounded what? It's compounded now annually. Number A. Number B, half yearly, which is semi-annual. Number C, it's quarterly. And number D, it's monthly. Now, let me remind you about the formula now. I'll write the formula here. We've got A is equals to P, open the bracket, 1 plus I to the exponent n. I told you the relationship between I and n. When it's annually straight, when it's half yearly, it means I you divide by 2 and you multiply by 2. So if it's half yearly, I you divide by 2 and n times 2. Then if it's quarterly, I divided by 4 and n times 4. Monthly, it implies that divided by that, and then n times 12. Now, I'm going to give you 5 minutes to solve this problem. Firstly, don't forget your SMS, your WhatsApp us to 064 748 8913. I repeat, our WhatsApp number is 064 748 8913. So don't forget to name your name of your school, and then you also WhatsApp us your solution so that we can acknowledge your solution. Please just try it. We are here to practice. It's a trial and error. If you made a mistake, it's fine, but just try to do it like I requested you. Bring your calculator, your pen, use them now. Please use them wisely, and then you are waiting. So I'm going to give you 5 minutes to go through that problem. Please just do it. 5 minutes. 5 minutes. Number 1. Sharp, sharp. Just go through it. Oh, thank you very much, good learners. Thank you very much. Bye bye, Danke. I hope you've done quite well. But please, before like you solve this one, you have identify this. You've got 20,000 and 3 years. Now we are doing it together, and then we've got the interest of 9%, interest rate of 9%. So you have to formulate your data. What is your P? It's 20,000 rand. I'm expecting this from your paper or your booklet. And then N is 3 years. I'm also expecting this data from your booklet. And then your I will be 9%, which is equivalent to 0.09. That's what I'm expecting you to do. And then all you just have to do, you just substitute, and then you do like I said. So let me erase this one now, because now we are moving towards our solution now. Let me not disrupt this one. We are moving towards our solution. That's what you are supposed to have. Now let us go to solution one. Solution one, number A, is straightforward. I think it took you less than a minute to solve that problem. Here it is. It's 20,000 for 3 years. Here is timeline. And then 0, 1, 2, 3. It's like a number line. So for first year, I think it's straightforward. What do we have here? Our P will remain the same. This one, it will be our I. And then, of course, our N will remain the same as 3. So can we proceed now? Don't get bored, please. You ask me to move slowly. That's what I'm trying to do now. Here is our solution, straightforward. So I think everyone got 25,958. Here is our principal. Our I here is 0.09, number of terms 3, like I illustrated before. So our answer is that. If you've got this one, congratulations, keep up the good work. But if you did not get it, then be with us, you will get it next time. You still have got time now to practice. So this one is our first solution. And now please, don't forget, we want to acknowledge your solution. Don't forget to SMS us to 064-748-8913, your solutions. We'll really appreciate that. We'll appreciate that. Can you proceed now? Please let us proceed to number B. Oh, half yearly. What did I say about half yearly? The way it's half. It's your loaf. It's your loaf of bread. You cut it half, then it's half. That you see, now you can see now our R is divided by 2. And then what's happening with our N now? We need to multiply our N by 2. What is our N? It's 3. Number of terms is 3, which is 3 times 2, which will be equivalent to 6. So you just substitute that. And then, can we move on? Here it is. Here it is. You've got 6 here. How did we get 6? We just said 3 times 2. Why? Because it's half yearly. And then we divided this one by 2, our I by 2, like I said in the beginning. Please don't forget our note. And then this is our solution. Then if you've got this one, we really appreciate that. You substituted correctly, and then there is our solution for number B. So I hope you are still with me. Now allow me to go to number C. Please don't get bored. Let us go to number C. This is our solution. Number C. Remember, the problem is still the same. Only the questions are different in terms of per annum quarterly. Now we talk about quarterly. I ask you, do not forget about this quarterly, because some of you just write 3. Please don't take it like that. Just take it from that grade 3 or grade R. You know, this is your loaf. I repeat, you cut it there. Sometimes they call it skambani or whatever. A quarter. So you eat 25%. This is 25%. It's equivalent to 25%. 25%, which is 25 over 100. In a fraction, and then simple form, it's a quarter. When you write it in simpler form. So here we have divided it by 4. What's happening with our n now? Don't forget, how much is our n? Our n is equivalent to 3, but now it's quarterly. What do we do with n? I said we multiply by 3, then we get 12. So we must get 12. So let us proceed. I think I've summarized this one as simpler as I can. Here it is. Here is our 12 now. Here, this is, we divided by 4, and then our solution is this one. I think you had the same solution with me. We are still in the same boat. Can we now proceed now? Let us proceed to the next one. Number D. Number D, it's monthly now. Per annum, how many months do we have? We've got 12. So what we did, we divide this I by 12. Then what we do now? We said we divide I by 12 and we multiply n by 12. So how much is our n? Our n is 3. So you have to multiply it by 12. So 3 times 12, it will give you how much? You know. So that's what we are expecting from our n. So how about we proceed now? That is why we've got the last term of 36. Because 3 multiplied by 12 will give us 36. Then can we go to our solution now? Let us share our solution. Look at yours. Look at mine. Here it is. Here is 36 because it's monthly, and then we divided it by this one by 12. And then here is our solution. So it's investigation different compound period. So we had 4 problems. Question is the same, different. So what can you tell me about this solution? What can you tell me about the solution? Look at the solution, and then we can share it together. Let us move on now. Now, interest can be calculated if compounded annually straight. Anything divided by 1, it's 1. Multiply by 1 is a thing. So that one is not a problem. Bulletin. If compounded semi-annually, it's half yearly. I told you, just divide by 2. Quarterly, you divide by 4, 25%. Monthly, you divide by 12. I think it's been elaborated. Let us proceed. Our final answer was 25,958 for number A. And then for number B, I hope you also got 26,045 and 25 and 20 cent. 26,045 and 20 cent. Can we go to number C now? 26,121. Straight, no cents. And remember, I told you we write our money into 2 decimal places. You can see always it's on 2 decimal places, please. And the last one, it's monthly. It gave us 26,172.98. So what do you think about those solutions? You can say something. You can write a book about this solution. You can write a story about this one. So without wasting any time, what do you think? Because we have to investigate different compound period. So you can write whatever you're finding, and then I've got mine here. So you can check if they are the same. How about you proceed, please? I'll try to move as slowly as I can, like you requested previously. Now, what happens to the value of the accumulated amount, which is A, as the number of compounding period increases during a year? Now, what's happening with this one? Accumulated amount. You know what's an accumulated amount? It's our A. So you can write it down. You can WhatsApp us to 064-748-8913. Please, I repeat, sorry for that. 064-748-8913. You will appreciate your participation on that. So just write it down, SMS, your finding about this one, and then we'll really appreciate that. So I think it will take you a second for that. So let us proceed and check if they are similar. Now, what happens to the value of the accumulated amount as the number of compound period increases during a year? Let's find out now. As the number of compound period increases, the value of accumulated amount becomes bigger. When this one increases, also this one increases. Directly proportion. If you already have written, it becomes directly proportion. It's fine. When the other one increases, the other one also increases. So it's directly proportion. When the other one decreases, well, also already other one decreases. So as the number of period increases, also the amount increases. So it's directly proportion. So I think you've got the same solution. How about we proceed now to another one? Because we don't have a lot of time. Remember, you did not do this one. So I'll try to move slowly because you have to expect this problem next year, grade 12, final exam. So grade 11, let us go on. Note, interest rate is always given per annum. Then the interest rate given per annum is then divided according to the compounding given. I think that one is clearly, you need to understand it. Interest rate is always given per annum. And then the interest rate given per annum is divided according to the compound given. What is given, whether it's compounded monthly, quarterly, etc. per annum. Then let us proceed. Let us look at this example one. Different compound period. Tando wants to have 25,000 rand in 3 years' time. Now, Tando, she wants to have 25,000 rand in 3 years' time. You need to read now. I know we are all mathematicians. I know. When it comes to reading, let us familiarize ourselves with reading. Please, this one we need to read. How much money, how much must she invest now if the interest rate is 8.5 per annum, compounded semi-annual? Now, all you need to do now, you have to formulate your data now. This, you've got 25,000 rand. She wants to have that 25,000 rand in her pocket. For how long? For 3 years. She need 25,000 rand in the period of 3 years. Now, she wanted to know how much must she invest. She must invest how much? If the interest rate is 8.5% per what? Per annum. Compounded what? Compounded semi-annual. Compounded semi-annual. Now, can I give you the formula again? Here is your formula. It's A is equals to P, open the bracket, 1 plus I to the exponent n. Remember, the formula is given at the back for this one. So you need to find out what is your 25,000. Is it A or P? At the end of this, she needs 25,000. So she wanted to know how much she must invest in order to accumulate 25,000 rand. For how long? For 3 years. At the interest of 8.5%. Now, I'm also going to give you this activity. 1 minute, you formulate your data. 1 minute, you substitute. I've also given you the correct formula. You substitute from this, and then 1 minute, you solve it. So I'm going to give you 3 minutes to go through this example one. Please, like I ask you, please have your pen, your paper, and your calculator, and tell me how much must she invest now in order to accumulate 25,000 rand at the end of 3 years. Please just do it. Please just do it. Just do it. Just do it. Please, we are here to learn. We are all here to learn. Just do it. I'm giving you 3 minutes, please, to go through that. And then I repeat, don't forget to WhatsApp us to 064 748 8913, your solutions. Now, please, after doing that, and don't forget to give us your name of your school. Just do it now. 3 minutes. Thank you very much. Just do it. Number 1, sharp, sharp. Oh, thank you very much for participation. Sakisizwe Pumlan, thank you for solution. We thank you very much. Your presence is highly appreciated. We got your solution. Keep up the good work. And others, just don't be shy, just do it. We are here to work together. Now let us go back. What do you have here? What is this 25,000? It will be equivalent to this one. And then how much she must invest? How much? Tando she must invest. And then what do you say semi-annual? What's the relationship between I and N? So our I, how much is our I? It will be how much now? 0,085 because we divide it by 100. And then how much it's our N? It's for 3. So it's semi. When you talk about semi, I told you, semi it's half yearly. Then what do? You just go and divide by 2. You multiply by 2. Now the challenge, it might be through simplification. Now let us go through that simplification. Let me erase this one. That's what you are supposed to have. Let us share this solution together. Let us share it together. Yes, the formula is given. I also have given you the formula. And then here we go. That's what you are supposed to do now. And then can we proceed now? What did we said? We said our A, that will be here. Tando wants how much? 25,000 final amount. And then how much she must invest? For how long? For 3 years. At what interest? 8,3. So 8,3%, which is going to 0,083 in decimal. And then we need to multiply this 3 by how much? By 2. And then we are looking for this. So I know now the challenge is going to be a simplification, but there's no problem. We'll do it together. I'm here to help you if you've got a challenge about simplification. And let's go on. That's it. That's like I said, you have to multiply this one by 2 and divide it by 2. Why? Because it's semi. And then we are looking for what? For P. Now let us go through this. If you've got this one, congratulations, good. So we've got 3 times 2, which is 6. Okay, we need to get rid of this now. We need to get rid of this. What do we do now? We need P, so it means what you can do here, because you need P. Remember, when you multiply, you divide. We need to make P subject to the formula. You can just write P is equals to 25,000 divided by the whole thing. Divide by the whole thing, please. 1 plus 0,085 divided by 2 to exponent 6. Just divide by the whole thing. Yes, because we need P here. You don't need to think hard. You need to think smart. We are just looking for P. So you divide by the whole expression. Just divide it by, and then you divide it here. So this, you put it here. You just divide it here. Then we'll have P. I think to be straight and forward. Just do it, please. Let me erase that one now. So I think the simplification here was not so much difficult. You just divide it by that, then it's gone. So let us proceed. Here it is. Yes, like it's repeated here. We need to divide by this, like so. Please. This. What you do on the left, you must also do on the right. It's a law of nature. Just do it. And then here is our solution. Oh, it's our solution now. So now you know what we did. Now we have just simplified this. Now we have simplified that. We have simplified that. Here it is. And then we need now, it means here we need to divide by 1,283678838. Also divide by 1,28366788838. That's what we need to do. We are just trying to move slowly but surely, because we have realized that simplification, it becomes a challenge now. So okay, we divided both sides by that, and then let us proceed. That's it. And then our P becomes that. I don't know how much did you get. Then this one becomes our solution. So just key it, please. Just key it and check how much you get. Just key it. Just do it, please, and check how much you get. Tandoshi must have the principal of 19,475,028 in order to accumulate 25,000 after 3 years. I think you are still in the same boat now. How about we proceed now? Please give me the opportunity to proceed. This becomes our principal amount. Like I said, you're not going to be asked always A. You can be asked about P, I, or N. So please, it's a matter of simplification. Don't forget your simplification. And then let us move on. Now, we are going to do now nominal and effective interest rate. What did I say? I said this one, the challenge is one, is not given in the formula sheet. When you go to your exam room, just memorize it. It's only one formula. I don't think it will be difficult. It's a nominal interest rate. So a nominal interest rate is an interest rate usually quoted by financial institutions. The quoted period and the compounding period are different. You will check that. It's a nominal interest rate. Can we go on now? E.g., 9% per annum. It's compounded what? Monthly. How about we go on? It's always per annum. It's compounded what? Monthly. And an effective interest rate. An effective rate, interest rate is an interest rate where the quoted period is the same as the compounding period. Let us look at the example. We've got 3% per annum. Compounded what? Annually. It's compounded annually. It's an effective interest rate. Now let us go through the example. The effective annual rate is denoted by this. This is the symbol. IEFF. IEFF, the effective annual rate is that. So some of you are not familiar to this. So please pay attention. I'll move a little bit slowly there because I know it's new to you, grade 11s. And then this is how is denoted. Annual, this one is denoted by IFF. And then the next one, there is a formula that helps to calculate the annual effective rate when given a nominal rate or vice versa. So like I said, this formula is not given. You need to know this formula. 1 plus effective rate is equals to, open the bracket, 1 plus nominal rate divided by the number of terms, close the bracket, to the exponent n. So you need to know this one, please. You need to know this one is not given, please. You need to know it. Now this one, IEFF, so it represents what? Annual effective rate. It represents that. And then I, like nominal rate. So I don't think you'll forget that from the way it's nominal. You see this one, it's a nominal, go hand in hand. And then effective, this one, it's an effective rate, always rate. And then let's go to the next one, number of compounding per year. So we've got only 3 unknown. 1, 2, and 3. So it's either if you are asked to calculate effective rate, you'll be given nominal and number of terms, number of compounding per year. So I'll simplify it, number of terms, and then how about we proceed? Please note this one is not, I repeat, is not given. I don't know how you can summarize it, but I know you will. You will. You just say 1 plus IFF equals to, open the bracket, 1 plus I normal divided by N. You close the bracket to this. Please note this one because I repeat is not given. How about we proceed now? Now here's an example number 2 now. Convert nominal rate of 15% per annum. Compounded what? Now I like it now. Compounded monthly. Compounded monthly. It's compounded monthly to an annual effective rate. Convert a nominal rate of 15% per annum. Compounded monthly to an effective rate. So what is given? This one is given. This one is given. And also this is given here. Compounded monthly. And then what do we need to find? We need to find this one. So I'm also going to give you 1 minute to solve this one. Please, I know we haven't done together, but just try it. Just try it. I've just given you the guidance, how to go through. Just try it, please. Just do it. I'll give you 1 minute because we are running short of time. Because we need to finish up this one. We need to do timeline also today. 1 minute. 1 minute. Go through this one, please. You need to calculate this one. Substitute and then find effective rate. Make effective rate subject of the formula. Please just do it. 1 minute, please. 1 minute. Thank you very much. Just do it. Oh, thank you very much. Welcome back. I think you've WhatsApp your solution to 064 748 8913. Now let us go through solution now. Or you can check it up. Check it up. Please just check it. And then if they are similar, no problem. Number 1. So let us go through. Yes. Like I said, this one is given. That's what we are looking for. Monthly. You see, now we continue with those terms. Monthly, here is 12. You put 12. And then you just substituted what is given. Yes, is 0,15. Then is 12 is 12. 1. Then you have to make this one subject of the formula. So it was only how many minutes? Only 3 minutes to substitute. 1 minute to formulate your data. Then let us go on. Here it is. We have just simplified it. 1 plus, you open the bracket, 1 plus your calculator, you know, you've got the bracket there. You write 0,15 divided by 12. You close the bracket to the exponent. There's a formula for that. It represents the exponent. You know how to use your calculator. So you can write to the exponent 12. And then here you get you must have this one. And then remember, we need to find this one. So we need to transpose that one. Our 1 to this side, it will change to become negative. So it will be 1,160,754,518 minus 1, or subtract 1. And then we did it. Here it is. Our solution moves step by step now. We are no longer summarizing our solutions. It moves step by step. Here it is. And then you're going to get what? 0,16075. We are going to get 0,160754518. That's what we must get, because 1 cancel 1. Okay? Here we go. Let me not spoil this solution. Here we go. Here it is. And then you just multiply by 100. You just multiply by 100. Because our solution must be in percentages. So therefore, you just multiply it by 100. And when you multiply by 100, you move twice. 1, 2, 16, etc. It must be 16,0, etc. Then that way you will answer according to the questions there. Whether you've been asked to leave your answer to 2 decimal places or whatever. Because this one are percentages, it's not money. Then here it goes. You multiply by that, we get how much? 16,07%. This is our effective rate. I think you got 16,07. But if your solution is end up here, you got the correct answer. Congratulations, keep up the good work. But don't forget now, you have to multiply it by 100 because it's always in percentages. So this is our solution, ladies and gentlemen. This is our solution. So go through your problem, and then this is how you must get it. So I think I've tried to move as slowly as I can because these ones are new. Okay, how about we move on now? Please let us move on. Now you've been asked to calculate effective rate. How about you have been asked to calculate the nominal? I'm also going to give you a chance to solve that. I'm also going to give you a 1 minute. I'm not going to just do it, go through the solution. You do it, you go through the solution, I go through the solution. We share the problem together. Remember, we're in the same boat. Né? Please, let us check the next one. The next one here. Now you've been asked, convert an annual effective rate of. Now, effective rate is given. It's given as 6,5% per annum to a nominal rate per annum. Compounded what? Now, quarterly. What should stick in your mind? Please, you must know it's 4. What should stick in your mind is 4. Because you talk about quarterly. I think I've illustrated that quarterly. I've tried to explain it as I can. I did my best to explain that. Remember, what should stick in your mind is 4. Now, what is given now? It's effective. This one is given. This one is also been given. We need to find this. I'm also going to give you a minute. Please, I'm also going to give you a minute to go through that. And then you can go through your textbook to practice others. Only a minute to go through the solution to calculate a nominal. Please, just do it. First, you substitute, and then just go through that. 1 minute, please, 1 minute, just do it. And don't forget Oh, thank you very much for your participation. Let us go through the solution now. Maybe 1 minute it was not enough. But I think what's most important here is that you have substituted correctly. And then what was left, it was simplification. I know simplification is a little bit of a challenge, but we'll move slowly to solve that. Okay, let us go through our solution. Here we've got, this is my bracket. What do you have? You've got this one, which is how much? 6.5%. And then we've got n, you know it's 4 because I've explained this one, etc. Let us go through the solution without wasting any time. Here it is. Here it is, our solution. So you have substituted correctly, you have write it into a decimal. And then there it is. First, you get a mark for substituting correctly. All right. You get a mark for this. So, of course, 1 plus 0, 0.065, it would be 1.065. And I think that one, no. There's no excuse. Then this one you have written as it is. What we did, we simplified only the left-hand side. Here it is. And now, like I said, you need to remove this 4. What did I say? If it's x squared, it equals to 4. Because it's square here, what we do is square root. Then if you get x to the exponent 3, it's equals to 4. What we do, keep root. Then the same thing, x to exponent 4 equals to 4. Remember your sets. That's what it means. So what does it mean? It means if it's like that, it will be 4, 1 over 3. This one becomes always our denominator. So this one is 2. Remember, it's 2. So here we've got 4. We want to get rid of 4. Remember squaring both sides. It's when you've been given maybe root x plus 2 is equals to 2. You square both sides. To what? To remove the square root. Now we've been given this, the fourth root. So it's to the exponent 4. We need to get rid of that. You still remember that you do the same thing. Whatever you do on the left, you must also do on the right. That's what we got. In order to get rid of that. So this is how it works. Now it's gone. This is what we have. So now we are left with this. So can we move on now again? So it means this, we are going to subtract it by 1. We are going to subtract it by 1. Let us go through our solution again. So it will be root 4, 1.065 minus 1. And then after we get the solution, we'll have that. So in order to, when we divide, we multiply. When we multiply, we divide. For instance, when I say 2x equals to 4, it's a multiplication. What do? I divide. So whatever I do, and so when I've got x divided by 2 is equals to 2, it's division. What do? I multiply. So that cancels that, x becomes 4. So same procedure here is division. What are we going to do? We are going to multiply. Inverse identity of simplification. So let us proceed now because we are still sharing the solution together. Here it is, here it is, here it is. Let me erase this one. Here we are. You see that? Minus 1. Here, minus 1. And then, what is left? We have to multiply it by 4. Sometimes you can just put the bracket here and multiply it by 4 in order to get rid of that. Or sometimes they call it cross multiplication. Cross multiplication, you can call it like that. It's fine. And then, there is our solution. You know what we did? We just simplify this one. Like I said, we'll move as slowly as we can. We have simplified this as it is. Here is the solution. So what's left, you just multiply by 4. Thank you. We multiplied by 4. Then what's left? Then we need to multiply by 4. We just move slowly but surely. That's what we did. And then we have to multiply this thing by 4. You have supposed to get this. Multiplied by 4, you are supposed to get this. Oh, remember what we are supposed to do now. We are supposed to multiply our solution by 100. Same procedure. Just multiply by 100. So when you multiply by 100, you move twice. 1, 2, 6,34. This will be our solution. That's good. Yes. Our is 3, 4. So it become 1, 2. So 6,35 because they ran it off. Yeah. 1, 2. Yes, it's fine. It becomes 6,35%. So you just multiply it by 100 here. You just multiply this one by 100. Then we get this. So this is how we calculate our nominal interest rate and then an effective rate. So this is how we calculate nominal and effective interest rate. I think you are all covered. So don't forget to share your solution with us, please. We'll appreciate that, because I've asked you to do this problem firstly, and then I understand about the simplification there. But we have tried to simplify it. We moved slowly, step by step. Let us proceed to another chapter, please, because we need to finish up this grade 11 work. Remember, we need to finish it up, because some of the school, it was not addressed finance. It was not addressed. So then you got an opportunity now to do it now. So let us do it. Let us proceed now. Calculations involving changing interest rate now. When dealing with complicated problems such as those with interest changes or additional deposit and withdrawal, it is advisable to use timeline. Timeline is nothing else. Please don't think hard, think smart. Timeline is nothing else. Number line. Number line. Everyone knows how to draw a number line. Let me remind you. 0, 1, 2, 3, 4, 5, 6, 7. That's all. 8, etc. That's number line. So when you speak about timelines, please don't think hard. No. It's the number line. This is number line. This is what we are going to do now. We're going to work through this number line. So everyone is familiar to this. Even grade 3 learner will be very happy to see that, because whatever you have been doing it continuously. So please, changing, so there will be subtraction and addition in terms of investment. So after 5 years you add, after 3 years you subtract. That's all about timeline. So our timeline, it will help us in terms of dividing those challenges. So when dealing with complicated problems such as those with interest changes or additional deposit and withdrawal, it is advisable to use timeline. In simpler mathematics, number line. That's what we already knows about that. Now, example 4. Now we are on timeline. It's a timeline. Oh, now this is new. This is new. Let us go through this one. It's new. But I don't think there's anything difficult. Let us try to make it as simple as you can. Let us look at example 4. Let us go through example 4 altogether slowly. Slowly but surely. 200,000 is deposited into a saving account. 200,000 is deposited into a saving account. The interest rate for the first 2 years. Oh, now we go to number line. You see that? For the first, let me draw the number line. Let me draw it here. Okay, the interest rate for the first 2 years of the saving is 9% per annum. Compounded what? Semi-annual. I like it, semi. Don't forget, please don't forget those terms, please. Thereafter, the interest rate changed to 15% per annum. Compounded what now? Monthly. After how long? After 2 years, the interest rate changes to that and that. Now the money is left to grow for a further 3 years. Oh, the money is also being left to grow for a further 3 years. Calculate the future value of the investment at the end of 5 years. It's 2 and 3. So let me give you the light. Let me give you the light. This is our number line. 0, 1, 2, 3, 4, and 5. How much is invested? It's 200,000. For how long? For 2 years. 200,000 is deposited into a saving account. The interest rate for the first 2 years of the saving is 9. So from this to here, we are here. The interest rate is how much? It's 9%. So 9%, let us write it as decimal, 0.09 per annum, compounded what? Semi. So what do you know about our I? So follow the interest rate for first 2 years. It's our N. Because they speak of semi, what's happening? You have to multiply this one by 2, and then we divided this one by 2. Yeah, it's still the same. You see that? It's still the same. Please, we still use the same formula. We use the same formula. A is equals to P, open the bracket, 1 plus I to the exponent N. This is how it works. Now, it's for the first. We are finished about the first. We underline this underline. And then, thereafter, the interest rate changes to 15%. The interest rate now changes to 15%, which is 0.50 in decimal fraction, 0.50 per annum. Compounded what now? Monthly. Now, what's happening about our N now? Our N we multiplied by 12. So, what is left? It's 3. So it means it can be 3 times 12. And then here we also divide it by 12. You can, let me give you the light. You can firstly do this one, be your first, and this one be your second. Remember, for the first one is 2 years. This is how it goes. And the next one is for 3 years. 0, 1, 2, 3. It's for 3 years. So 9%, 20,000, 200,000 is deposited into account. For how long? For 2 years at the interest of 9%, which is 0.09 in decimal. What? Compounded semi. Because semi, what should stick in your mind is 2. This is divided by 2. So the formula is still the same. The formula is still, firstly, let me give you the light. You start with this one first. You start with this one. You start with that one. The formula is still the same. The formula is still the same. You start with that one. And then when it comes to this one, it means your final amount will become the principal. Your final amount will become, because it continue. So you'll get, it means 200,000 will change now. Then you're going to substitute it here for number 2. Just try to do it slowly, half. Some of you, I know you can just do it straight. So just try to do it. So how long do you need for this one? I'm just going to give you 2 to 5 minutes. Just try it. I know I'm just trying to I've introduced it to you. So I was trying to give you some light on how to solve this one. So this is what I did. We did it together, this one. This is our map. So first you start with this one. Remember, you continue to this one. So I'm also going to give you 5 minutes. You solve this one firstly, and then your A here will becomes P on the next problem because it continues. So I'm going to give you 5 minutes. Please just try to do it. Just try it. Just try. I'm not expecting a correct solution. We all learn from mistakes. So mistakes are there to be rectified. So problems are there to be solved. So let us try it. Please, I'm giving you 5 minutes. Please, I'm begging you. Just try to do it. Please. Just do it. Thank you very much. But don't forget to SMS your solution again to 064 748 8913. Just do it. If you've got a friend next to you, your teacher, your friend, whatever, just do it together. And then don't forget to SMS the name of your school. Sharp, sharp. Just do it. Number one. Oh, thank you very much. Welcome back. Sakisizo, I can see you are still busy, and Pumlan High School. Now let us just do it together. Thank you very much for your participation. And then please remember it's WhatsApp number. There are 3 methods to solve this problem, but I've introduced only one method so that I think it's much easier for you. The first one, you just simplify this. The second one, you just continue with that. The other one, someone you can just go straight with the same amount. Because this one changes. With the method I've introduced to you now, this one will change again and then becomes your principal. So there are 3 methods. The first method I think is straightforward. It's much easier. And then you go to another second method and third method, depending to you which one is simpler to you. So let us go through the solutions now. Let me erase this one. I think you still have this because I'm just going to draw it nicely so that you can understand very well. This is our number line. We've got 200,000, which is deposited. For 2 years. So let me say this one, 0. This one will be your 2. Okay. And then wait, at 9% semi. I think I've summarized that on that side. First, you work out this one first. Just work it out. And then after that, you come to the next one. Because now the principal is going to change. And then you continue to the next one. And then let us analyze that. The other one, then we move from 2 to 5 years. Yes, which interest of 15% for 3 years. So our number line is correct. It's from 0 to 5. So it's only changes of interest rate and then compound annually, and the other one is monthly. So we still remember this. When you speak of monthly, what you stick in your mind is 12. Semi is half. It's 2. And then that's it. Let us go. This is method 1. I requested you to solve this one. Method 1. It's as easy as a pie. Let's do it. First, 2 years. That's it. Where it goes now. This is our solution now. Remember, this one becomes 0.09 because it's semi. You divide by 2. For how long? This is your I. And then we've got N, which is how much? It's for 2 years. Because it's semi, you multiply by 2, give us how much? 4. So here it's 4 for N. We divide it by 2 for that. So this is our solution. So we continue with this one because now remember it continuously. And I think you've got it correct for this one. It was straightforward. At least no 0 in mathematics. Anything times 0 is 0, divided by 0 is 0. So no question we must get 0. So you got the mark for that. So let us add another one. In the last 3 years, you see now, like I said, your principal is going to change. Now it's from 200,000 and it changes to this amount. Now it's what? It's 15, which is equivalent to 0.15 divided by how much? 12. What do we have? It's I. What we have here, we've got number of terms. Now what's left is 3. We times how much? 12. Like I did. It's 12. So this gives us how much? 36. So here it is. Here is our solution. Here is our solution. This is method 1. I hope Everyone is understood. Now, when you go to method 2, please check it. Check this. Check this. Please check this. Let me raise this now. So this one remains the same. You understand? This one is understood. When you go to method 2 now, check this. Check that. This it's all about method 2. This one. It's all about method 2. This 1 and 2. So let us go through method 2 now. So our final answer is that. We are still on method 1. So when you go to method 2, you check that. So this will be our solution. Remember, why? Like I said, we write money into 2 decimal places. We have just simplified this one. 373,006,42. Because here it's number greater than 5, 6, etc. We just add by that. This one becomes our solution. We write money into 2 decimal places. Please don't forget. This is our solution now. So method 2, we check that and that. I'm just trying to summarize that. Here it is. You see that? This is method 2 now. Because you carry on for the first 2 years, you carry on for the next third year with the same amount. You just multiply with the same amount. So it means it remains the same as 200,000. Open the bracket, 1 plus 0.09 divided by 2 because it was semi. And then 2 times 2 it becomes 4. You just open the bracket, then it implies to that. 1 plus, how much is interest rate? 0.15 compounded monthly. For how long? For 3. 3 times 12 is 36. So it's 3 times 12 is 2 times 2. So it goes on. It's as easy as that. You just go 200,000. 1, 2, 3. Open the bracket, 1 plus 0.09 divided by 2 to exponent 4. Open the bracket is that one again. 1 plus 0.15 divided by 12. 3 times 12 is 36. Here it is. There it is. Straight. That's the method 2. But if you understand method 1, then the method 2 becomes easy now. And then the same procedure, the same answer. You can key your calculator, you can get the same answer. And then this is method 2 for the solution. Then you still got another method. Don't forget. Now, example 5 now. Thabo deposits 6,000 into a saving account. 5 years later, 2,000 is added to the savings. So remember, here, nothing was added, nothing was subtracted. There was no addition, there was no subtraction. It was only that amount, straight, of 200,000. So the next question, now, it says that Thabo deposits 6,000 into a saving account. 5 years later, 2,000 is added to the savings. The interest rate for the first 3 years is that per annum, compounded semi. Thereafter, the interest rate changed to 10% per annum compounded monthly. Almost everything is still the same. Calculate the future value of the saving at the end of 7 years. So it's still the same. When you draw your number line, so we talk of 7 years now. 0, 1, 2, 3, 4, 5, 6. 0, 1, 2, 3, 4, 5, 6. Okay, 7. Okay, we end up here. So Thabo deposit how much? 6,000. into a saving account. 5 years later, 2000 is after 2000 is added. You see down I write plus 2000. After 5 years, 2000 is added. 5 years later, added. The interest rate of the first three is that. The interest rate of the first 3 years is 10%. The first 3 years is 10%, which is 0.01 per annum compounded semi. You just divide by 2. Thereafter, the interest rate changes to 10% per annum compounded monthly. Now it changes to what now? To monthly. Calculate the future value. Then after that, yeah, it changes to that. So, due to time, I'm not going to give you some little bit time now because we are running short of time. We are just going to do it together now. So the different here, we need to just add 2000 after that. So let us go through the solution. This is our number line. Let's draw a number line. Yes. Please, I'm not going to give you time to go through this one because we are running short of time. Yes, 6,000 is deposited. It's our number line. We move for 5 years. At what interest rate? Then 2000 is added. You see now, it's not subtracted, it's added. If it's subtracted, it means it will be minus 2000. We've got 3 years. 10%. Okay. And then we've got 2 years. And then after that, it finishes up to the last 7 years. This is our timeline. That's it. It remained the same, but only 2000 was added. So let us go through that. This is our timeline. Yes. So let us check number of terms. It's 3 plus 2. It's 5. 5 plus 2 is 7. So our number line is all right. Timeline is correct. And then 2 years, 2000 was added. And then it's finished up. Then let us go there. Yes, this is our timeline. Value after 3 years. Now, after 3 years, we go straight. The formula is still the same. There's no problem for 3 years. It is. So it tells us the story. So it's that divide by 2. That means when you divide by 2, talk of half yearly or semi. This is our solution. Then after the end of this one is after the end of 5 years. That. And right. So it means here you just add 2000. Just add 2000. You can just add 2000 here. It's still the same. And then here it's our solution here. Solution. And then here it goes. But we must recognize something here. Our principal it changes. It changes. Here it was here. We got this. It becomes that. Now we've got that. And then it continues now. This one will be our principal now. At the end of 7 years, you're left with 2 now. Yes, still the formula? Yes, of course you are left with 2. So for monthly. Now it's monthly now. It's monthly. You've got 2. You got 2 times. And then you've got that number of times will be 2. And then there it goes. So you see that it comes here now. This one. It comes here. So here it becomes our final solution. Also, it's also written into decimal places. The method 2, let us go to method 2, please, quickly. We do the same thing. You just add 200,000, etc. Then this one is for last one. So it means this one and that. And then this one is the last one. That's what we did, this one. This one, it represents that. And then this, it represents this. Just go straight. and then you can key your calculator, the answer is still the same. If you understand the method 1, the method 2 will be easy for you. And then, sorry for not giving you the opportunity to just practice due to time, but I think we are still together. And then method 3, the last method, it's also straight. That's it. The method 3, what we did, we took this and that, and then this one becomes the last one. So that represented by the star, this is that. But here, remember, our principal amount doesn't change here because you just take it straight. Okay? I think you are all covered. I'll give you a minute to solve this one. I think that's all about today's lesson. And then that's the solution is still the same. Still the same. And example 6, you can just copy it and try to solve it by yourself. And you can just turbo deposit. But now the difference here is that 5 years later, 2000 is what here? It's withdrawn. It's withdrawn. So everything is still the same, but here on the second activity it's minus 2000. Everything is still the same. Here is just that you are going to separate it by negative 2000 because here it was 2000 is added. Let's check the next one. Check it, they are still the same. Here it's withdrawn. 2000 is withdrawn. It's on our number line. You'll see everything is still the same. The amount is still the same. Period is still the same. Everything is still the same. But here you must get negative because it's withdrawn. So it's 5 years. You see that? Then it's negative because 2000 is been withdrawn. Okay. Here, the last activity 2000 was added, and then here it goes. Everything is still the same. It's gonna be 2 here, and then the last one here, it's gonna be 2. Number line remain the same. You see that it's 2 now, so it's still the same. 5 plus 2 is 7. 2000 is withdrawn, so the difference here is just that you just subtract 2000. The value after 3 years, I think it's still the same. The value after 3 years is still the same. After 5 years, it will change because you need to subtract now. We don't add. That's it. We subtract now. And then we get this. After 7 years, we go down with this. That's it. And this is our solution. So the method 2, you see that? We also took this and that. Check it, this one. And then this one. But remember, method 2, the principal doesn't change. And that. So the example 3 is still the same. You still remember, we end up with what? Yes, still the same. Yes. And then we end up with this one. It's represented by the star, this and that. This one is a star, that and that. It's still the same with the same method. The difference here, it was only 2000 was subtracted. And then here we go. Then we get 9,534 and 48 cents. So we get 9,534,48. So what was your solution from the previous one? Okay, that's it. Let's check. Let me not disturb you with this one now because it's explained. Method 3. Yep. Yebo. And that's it. The formula is still the same. Yes. Like I illustrated, we just subtract. I think you can check. The first one, from the final solution, you just subtract by 2000. You must get this. From the first activity, you just subtract by 2000. The method is still the same. You just subtract by 2000, you're going to get the solution of 9,534 and 48 cents. And then today, that will be the end of this activity. I think you have enjoyed it, and I hope you did not move a little bit faster because I've given you the same activity, but the difference it was the first activity 2000 was added, the next activity 2000 was subtracted. Okay, I think you have enjoyed this activity, and then I hope you enjoy your whole day. Thank you very much for watching this lesson. Please remember to sanitize, wear your mask, maintain social distance, and keep safe. See you next time. Goodbye. Sharp, sharp.